Okay, so here is the answer for the blurring exercise. This is a very difficult problem. Going through it, this is quite complicated. So I wrote a test just to make sure that my assumptions are correct. You can write more tests and you'll get a better verification that everything is working. So first we have the blur test. And this is going to run. And first we create a test array and we give it a set of values. This is a two-dimensional array. Then we create an image, a new image based on that, passing in the first, second, and third element, which arrays are indexed starting at 0, so 0, 1, 2. Then we assert that the outer array, which is the one that gets created right here, and remember that this asterisk there means to create an empty array, and every single argument becomes an element in that array. So now we've got a two-dimensional array there, we've got a two-dimensional array here, and we assert these two things are equal to each other, and if not, it's going to say test array and image array do not match. We run our test, and yes, it is, and we verify that our test is working by changing something, and then seeing if it fails, and it does. So right here we can clearly see that it did not work, and then it gives you like exactly what the thing is that didn't work. Let's revert that, save it, run it again, and we're back to passing. Next, and the more important thing, is that what's supposed to happen is that wherever there's a 1, each adjacent element should also change to a 1. So this should be a 1, that should be a 1, that should be a 1, and that should be a 1. Next, whenever we get down here, this should become a 1, this should become a 1, this should become a 1, and then over here, this should become a 1, and that should become a 1. So whenever we look through the expectation of what's going to happen, we write that assertion out. Then we call the blur method. Then we have this thing called a new outer array, which is this is the variable holder of our new array. One of the things you'll learn in programming is that mutations are bad, which means changing things can have unexpected and unintentional consequences. So as much as possible, you do not want to mutate elements. You want to create a new element and change that. So that's why we have a new outer array, because we want our original outer array to stay exactly the same. Then we assert that our blurred array expectation, this one, what I said was going to happen, is in fact what actually happened. And if those two things do not match, then we're going to get an error. So we can always again verify this, change something to make it fail. It does indeed fail. Revert it back, save it, run it again, and we're back to passing. So we know all this stuff works now. Now here's the tricky part. We define two things, one of which is output image. This here is just a method for printing things out. We're not actually printing anything out to the console here, but this again ensures that we don't have a mutation. And then here is where the meat and potatoes of all this happens. So the very first thing we do is we get the length of the outer array. Remember that arrays start at 0, or 0 indexing as it's known. The length, though, starts at 1, which means it will be length of 5, but end at R of 4. So that means whenever we're testing for the max length, we need to make sure that it's less than whatever the length is. Make sure it is not equal to the length. Next thing we do is we use our instance variable, new outer array, and then we call this method here. What this does is it does what's known as making a deep copy of an element in Ruby. Ruby by default, if you set value A equal to value B, it will mutate both of them. The two things are equivalent in memory. So in order to get around that, this Marshall load and then Marshall dump the outer array creates a completely brand new version of the original array. And so whenever we make a modification to the new outer array, it will not mutate anything on the outer array that we initially declared right here. So this is one of the advanced concepts that I don't know if it's been covered. And of course there are other solutions than what I'm showing you here for this problem, but this should work. Or actually it does work, at least as far as the tests that I've written at this point so far. If you write more tests, you may find there may be some bug that I'm not catching. All right, so our next thing is we create an array checker. And the array checker is going to be used to change array elements in the future. This is kind of being a little overprotective. You don't actually need this step. You can change things directly because we created a copy of this new outer array. It should not cause a problem if we directly mutate things out of order. But just to be safe, I am in fact creating an array checker. Next, we use the each with index method. Normally when you do .each, it gives you the value, but it does not give you the index element that goes along with that. When you do each with index, you get the value inside of the array, but you also get what number in the array it is, 0, 1, 2, 3, etc. So we need to be able to mutate all the tests, yeah. So we need to be able to mutate the variables to the up and down from wherever we got a 1 at. In order to do that, we create the previous outer index, which is whatever the current outer index is, minus 1, so that'll be whatever was before that. And then the next outer index is the outer array index plus 1, which will then be the next element over here. Once we have that in place, we then loop through the inner array, also with the index. And then we have the individual element, which that's going to be the 0 or 1. And then we have the inner R index, which is whatever position it is at, so 0, 1, 2, 3. Once again, we now need to get the length of this array. So we do that. And then, as before, we now need to get the previous indexes. So instead of up and down, now that we're on the inner array, we're looking for left and right. So we go -1 and +1. If it's a 0, then we don't do anything. So pretty much 0 stay the same. But if it's a 1, that's whenever we start having to do some fairly complicated logic. So first, if the previous outer index, which means the element before that, is greater than or equal to 0, because if we're looking at the 0 element right here, before this is -1, which will give you an index out of bounds error. It's going to say that there is no such thing as a -1 index position for this array. So it's going to throw an error there. So to prevent that, we say if it's greater than or equal to 0, so if it's this or anything else. Then in our new outer array, we're going to take the previous outer index right there. Then we're going to take the inner array index. So it'll be this thing on this position going up 1. And we're going to set that equal to 1. Then we say if the next outer index, so that would be this one right here, if that is less than the outer array max length, so if it's 5, then if it's less than 5, it will be valid. We put this into the array checker and we push the next outer object and the inner array index into it. So we're saying, hold on to this. Whenever we get to that next piece, change it. This is a step I don't think you actually need to do. I think it would work perfectly fine if you did this instead. So we'll do this and this. That's fine. I think that would work perfectly fine. Let's run the test and find out. And yes, it is. This is just one way of making sure that the value doesn't mutate. So if you didn't have a cloned copy right here, if you were to change the next value, then whenever the loop keeps running, it's going to pick up that next value when it hits it, and pretty much going to turn everything into 1s. You're going to get the wrong count because it's going to cascade the 1s to every single value up, down, left, and right. And so each time it loops through, it's just going to keep picking up more and more stuff. So that's what this was for, but we don't actually need it. Then we say if the previous index is greater than or equal to 0, so we're back to this. So it's one of these things. If it's this one and we go 1 back, it's going to be -1, again, out of index, so we don't want that. So if the previous inner index is greater than or equal to 0, then our new outer array equals the outer array index, so whatever one of these it's in, one of those rows, and then the previous inner index value, so whatever column it is inside of there, we set that equal to 1. Then we have the next inner index. If that is less than the max length of the inner array, once again, we use the array checker to push on that. And as before, I don't think that's necessary. I think outer array and next inner index, we will do that. Run our tests again, still passing. So we don't have to do that. Finally, we get to the end of this. And this is where if you didn't mutate the array directly, like this, then we would run the array checker and we would say if it has whatever the outer index is, and then whatever the inner index is, right here, if that doesn't equal nil, if the index finder doesn't find anything, it returns nil, then we set the outer index and the inner index equal to 1, which is then going to find, let's say it's 3, 2. There we go. So 0, 1, 2, 3, and then 0, 1, 2. We change this to a 1, for example. And that is it. That is the entire thing. So it's fairly complicated. It uses a lot of conditional logic. There might be prettier or nicer ways to do this, but this is a working example, shall we say. And you can write more tests to verify that it works, because one of the things about tests is they can give a false sense of confidence if you do not run them through enough scenarios. The more scenarios you run inside your test, the more confidence you can have that you've caught all possible variations. So, but even if it's not 100% correct, I'm confident that the answer is going to look at least something similar to this, even though if how I did it is not how another person would do it. So hopefully that answers your question on this, and I will post this video up and see you next week, or this week upcoming.